Good afternoon, everyone. I am Adedoyin Jeremiah. I'm popularly known as Presidomath or Jerry Springer. This video I'm going to do now is for second year students in the university or third year students in any polytechnic. And this video will be on mathematical method or advanced calculus. So I'm going to start with reduction formula. I'm doing reduction formula now, and we'll go like that till we get to the first order differential equation. This is the first lecture on reduction formula. I'm going to do this and we'll go from there. I would like you to help me subscribe to my YouTube channel, comment and like my video. You can also help me send to people that also need this mathematics or this reduction formula as well. Thank you very much. The first thing is I'm going to talk about the reduction formula. I'm going to go straight to the point. Number one is the first thing I want to do is I want to do the reduction formula for sine nx. That is, obtain the reduction formula for integral sine nx dx. So the first thing is we want to obtain the reduction formula. What does the reduction formula mean? The purpose or the aim of reduction formula is that this is sine nx dx. That is, we want to reduce the power. We are not solving it directly, but we want to reduce the power in such a way that by the time we reduce the power, by the time we now have questions to solve, it will be much easier for us to just apply the formula and we use it to solve. Now the first thing is I'll call this Sn, let Sn be equal to the integral of sine ns ds. So I want to obtain the reduction formula for this. So now, what will happen here is that I will do something. Sn will be equal to the integral of sine n minus 1s multiplied by sine s dx. Of course, this is raised to power n, and this is n minus 1. So I brought out one of the signs so that I have this. Of course, why have I done this? The reason why I do this is because I want to use the method of integration by parts. I want to use the method of integration by parts to solve this. So the first thing is I will let you to be sine raised to power n minus 1s. I'll let you to be equal to this, then dv to be equal to sine s ds. So I will differentiate this du ds will be equal to, since I have sine ns, suppose I have sine square s. If I want to differentiate this, these two will come down first. That will be 2. Then I have sine square s. You subtract 1 from the power, then multiply by the, you differentiate sine s, you have cos s, so that you have 2 sine s cos s. So that's basic. That's just how we solve during the differentiation. Or better still, don't forget you are going to use chain rule. Whenever you want to do this, maybe you have sine square s and you are told to differentiate. You will use chain rule. You will let u to be sine s, so that you now have u square. You will now do dy du. Dy du will be 2u. Then you will now multiply by du ds. Don't forget you have let u to be sine x. Then du ds will now be cos s, because you differentiate this. So you will now have u is sine s. Don't forget. So you now have 2 sine s cos s. If you are not careful with it, just try to differentiate using chain rule. Let y be equal to this. Then let u be sine s. And use chain rule. You understand what I'm trying to say. But in this case, the power is n minus 1. I will be integrating I will be differentiating directly and integrating directly as well. I will not waste time explaining basic concept like this. So, but I will explain to you with mouth, but I will not necessarily write it down. So what happened is that this n minus 1 will come down. This is the power, it's just like this 2. The power 2 will come down, but so this n minus 1 will come down to become n minus 1. Then this one will now become sine n minus 2s. Then differentiate sine s, you have cos s. So if you differentiate this, or you can do that on your own as well, differentiate sine n minus 1x, you get n minus 1 sine n minus 2s cos s. That's what you are going to have. Then this one, this one you have to integrate. Integrating both sides, integrate sine s, you have minus cos s. Integrating sine s, you have minus cos s. So that means that the u will now be equal to n minus 1 sine n minus 2s cos s. Then the s will now be s, so but v will be minus cos s. So that's what I'm going to have. So I'm now going to use my integration by parts. I'm going to use integration by part. What does integration by part says? Integration by part says that so that means this s, and I will not be writing this big cumbersome expression. I'll just write it with Sn. So that means Sn will be equal to, don't forget I'm using integration by parts. Integration by parts will be uv minus integral of v du. So Sn will be equal to uv. U is sine, this v. So that's minus sine n minus 1s cos s minus integral of v. V is minus cos s multiplied by du. Du is n minus 1 sine n minus 2s cos s ds. So Sn will be equal to minus sine n minus 1s cos s. Minus times minus with the plus, and n minus 1 is coefficient, is a constant. Integral of our have sine n minus 2s cos square s ds. So what do I have next? I have Sn to be equal to minus sine n minus 1s cos s plus now n minus 1 integral of sine n minus 2s. From trigonometry ratio, sine square theta plus cos square theta will give me 1. So cos square theta is 1 minus sine square theta, 1 minus sine square x, or sine square theta. So that's what I have. So this one will now be Sn to be equal to minus sine n minus 1s cos s plus n minus 1. This one will now be integral of sine, and if you open the bracket, n minus 2s ds minus integral of sine ns ds. So don't forget the aim is to reduce this raised power n. So Sn will now be equal to minus sine n minus 1s cos s plus this one will now be n minus 1. So I call Sn to be equal to integral of sine ns ds. So integral of sine n minus 2s ds will be Sn minus 2. That's what I'm going to use to denote it. Minus, this is also Sn, because that is sine ns. That's the question. Sine ns. So that's also sine ns here. That's what I have. So that Sn will now be equal to minus sine n minus 1s cos s plus n minus 1 Sn minus 2. My plus times minus is minus. This is n minus 1 Sn. So that is what we are going to obtain. After I'm done with everything, I'm going to explain to you how they came to each other. Collect like terms. This is Sn and Sn is here. Bring them to the other side. This one will become Sn plus n minus 1 Sn is equal to minus sine n minus 1s cos s plus n minus 1 Sn minus 2. By the time you simplify all these things here, this one will be, if you factorize Sn, this will be 1 plus n minus 1. And 1 plus n minus 1 will just be n. So all this one here will now become n Sn is equal to minus sine n minus 1s cos s plus n minus 1 Sn minus 2. Divide through by n. So Sn will be minus 1 over n sine n minus 1s cos s plus n minus 1 over n Sn minus 2. And this is what we call the reduction formula. That is what we call the reduction formula for sine ns. So of course you can see this Sn minus 2 is integral of sine n minus 2s ds. So the implication is just that we have reduced it from n to Sn minus 2. And why this is Sn, don't forget I denote Sn to be the question. So and that's what we have here. Again, let me just rush through it in case you don't get it at one point or the other. I want to reduce sine ns ds. Sn equal, I now do sine n minus 1s, then multiply by sine s ds. That's what I have. So you will now let u to be this. You will let dv to be, or the remaining one will be dv. This is u dv. So by what I'm using is it's called integration by parts. So u equals sine n minus 1x and dv is equal to this. So differentiate this. The u df should be equal to n minus 1 sine n minus 2 cos x. How? This n minus 1, don't forget the power will come down. This will come and subtract 1 from the power. 1 minus 1 will give me minus, so that's why I have sine n minus 2. Differentiate sine x itself cos x. That's what I have here. So then let this ds come to the other side. The u equal n minus 1 sine n minus 2x cos s ds. Then integrating this, don't forget this one is same thing as integrating both sides. The point is that you will integrate this. So v will be equal to minus cos s. If you integrate sine s, you have minus cos s. So that v will be minus cos s. So I just decided to write the formula for integration by parts. Integration by parts will be u v minus integral of v du. So u and v, this is u, this is u, this is v. So this is minus sine n minus 1 cos s minus integral of v, this is v du. The minus will come outside to become plus. N minus 1 is also a constant. It will come outside. Cos times cos square, and it remains the sine n minus 2s ds. So this is n minus 1 from trigonometry sine square theta plus cos square theta will give us 1. So cos square theta is 1 minus sine square theta. By the time you expand, sine n minus 2s times 1 sine n minus 2s. Sine n minus 2 times this one, it will make it n back. It will bring it back to n. So which is what I have here. All these ones are still the same to this point. Then this one will be denoted as Sn minus 2 minus Sn. Then bring it to the, open the brackets so that this one will be attached to it. Then bring it to the other side. This one will become n. If you factorize Sn here, it becomes, you factorize, this one will be 1 plus, you will have n minus 1. You factorize Sn, 1 minus 1 is 0, it remains n. That's why this is Nsn. So that's what I have there, and we obtain this